Hi guys, today we're going to be doing chapter 1-3, which is on open sentences. So we're going to be doing a lot of true false like things today. So open sentences is a mathematical statement with one or more variables. Pretty much it's an equation that they have a letter in simple terms. Solving the open sentence, the process of finding the value for a variable that results in a true sentence. Basically, that's what we're going to be trying to do. They're going to give us a bunch of numbers. We got to plug them in and figure out which one works best. The solution is the replacement value is an open sentence, so whatever we get for it. An equation is a problem with an equal sign, really. A replacement set is what we are going to be plugging in to the problem. A set is the numbers, collection of objects or numbers, and an element is one thing. So if you took an idea, a set would be like this right here. This is a set of numbers, okay? An element would be like that. That is one element. So the whole thing would be a set. Just one of them is a number or an element. So doing this, honestly, it's all just plug in and solve. So we're going to just go, this is what we plug in for n right here. And we're just going to plug it into this equation right here. And we're going to figure out which one's true or false. And we only need one true answer. So once you find your true answer, you're done. So 6 times 3 plus 7. And we want it to equal 37. Well, this is going to be 18 plus 7 does not equal 37. So 6 times 4 plus 7 gives me 24 plus 7 does not equal 37. 6 times 5 plus 7 gives me 30 plus 7. That equals 37. So my answer here would be 5. And then you're done. You don't have to keep going because obviously with equals, only one thing is going to work here. So all of this stuff right here isn't going to work. We just got to find the one that does. Now, there will be times that none of them work. If none of them work, that is a no solution. So that is good to check. So, but we did find one that worked. So once we found one that worked, we're done. We got the one we need. Same thing here. So we're going to plug all these numbers right here into this equation right here for x. I know it says n, should be an x. So 5 times 1 plus 2. 5 times 3 plus 2. 5 times 5 plus 2. 5 times 7 plus 2. 5 times 9 plus 2. I'm just writing them all in, and then if we find one that works, we find one that works. So this is going to be 5 times 3. Does not work out. Does not give me 40. 5 times 5 does not give me 40. Remember, we're looking for this answer right here. 5 times 7 does not give me 40. 5 times 9 does not give me 40. 5 times 11 does not give me 40. So none of them worked. So in this solution set, my answer would be no solution. Okay, let's try one more right here. So, like I said, you take these numbers and you plug it into this equation right here. And we want it to equal 12 when everything is said and done. So 3 times 2 minus, I'm just going to simplify this right here. See how we're going to have to do that every time. That's going to be 3. 3 times 3 minus 3. 3 times 4 minus 3. And if you see what I'm doing, I'm just starting out all the problems the same, because then we already have them all set up and we don't have to fill in all that stuff. So 3 times 2 minus 3. This, remember, that part gave me 3. So that'll be 6 minus 3 does not give me 12. 9 minus 3, or 3 times 3 is 9 minus 3, does not give me 12. 12 minus 3. I got 12 from 3 times 4. So 3 times 4 minus 3 does not give me 12. 3 times 5 is 15 minus 3. That one does give me 12. So all those didn't work, and that one's not going to work. So my answer is 5. All right, last thing, but then we're done for the day on this video, is Using order of operations to solve an equation. So remember, I just wanted to get a little bit extra practice from like we did yesterday with the fraction bars. Fraction bars, you break it into two parts. You have a top half and you have the bottom half. Okay, so I'm gonna do the top half first. 2 times 4 is 8, so 13 plus 8 is 21. Now 5 minus 4, because you gotta do parentheses for it first, so 3 times 5 minus 4 is 1. 3 times 1 is 3. So now we got 21 over 3. Now, that's a fraction. Does 3 go into 21 perfectly? Yes, it goes in there 7 times. So then my answer would be 7. Okay, now the only difference from yesterday to today is now we have this little plus 6 at the end. We're not going to worry about that till the end. So what I'm going to do is I'm going to put a fraction bar over here, and then I'm going to put plus 6. So then I know to do that. Okay, so we're going to start 7 times 3 plus 3. We're just doing the top part now. So 7 times 3 is 21, plus 3 is 24 on top over here. And then 4 times 3 minus 1, so 4 times 2 gives me 8. Now I have to simplify this fraction first before I can add it to this. So does 8 go into 24 perfect amount? Yes, 8 goes into 24 3 times, plus 6. So now this is where that plus 6 comes in. 3 plus 6 is 9. And that's it, guys. That's all we're working on today. So hopefully that made sense. If you have any questions, remember, always write them down, bring them prepared to class or a Google Meet with me, and then we can talk about them as a group. Thank you.